In this video, we are going to solve some integrals involving e to the x. So let's get started. The first ones are what I call the self-type. And the self-type is essentially when you have a situation like this. So you have e to the x dx. So the solution to this is e to the x plus c. So another one, let's say you have 2e to the x dx. So this is just a constant, comes outside, so it's 2e to the x. What I mean by this is that anytime that you have a constant outside, like in this case, so let's say it's 10 and you have this, you're essentially ignoring the integral. You're not ignoring, but when you look at it to solve it, essentially it's the same thing. Okay, this is what I mean by this. So these are what I call the self-integrals. Now the next type of integrals involving e that we have, it's a different type. It's what I call equals 1. I'll give you some examples. So let's say we have this situation, e to the 2x dx. The solution to this is 1/2 e to the 2x. And what I mean by when I say that these integrals are the ones that I call equal to 1, because whatever number that you have here, you just need to divide by the same number here. So another example would be, let's say you have e and then x divided by 2 dx. So you need to get 1, right? So in this specific case, you need to divide by something that it's essentially the same number in order to get 1. Here you multiply by the same number to get 1 again and leave the rest the same. So the solution to this one is 2ex divided by 2 plus the constant, and also the constant here. Okay, the other ones are quite similar as well. So let me get a different color. So let's say you have this one. So you have e to the x plus 1 dx. The solution to this one is exactly like the other one. So it's e x plus 1 plus c. And this also works if you add like a difference. So it's x minus 5, for instance, dx. So it's the same thing, e x minus 5 plus c. So there are more complicated examples with e to the x, but I just wanted you, for when you are doing some exams and some proofs, in order to look at them and make it much easier. So e to the x, because the integral is the same as the derivative and also like the reverse. So there are some properties when you look at it, you can solve it immediately. So the first one that we saw, if you have a number here, it's a constant, comes outside. But because the integral doesn't change, it's the same. So essentially it's like removing, in a way, the integral. So same thing here. The other cases are what I call equals 1. So if you have something that is multiplying, you just divide it outside to get the final answer. The same thing here. When you have something divided, you just need to multiply by the same number. And this is what we have here in order to get the final answer. Let's work on another example. So let's say this time we have this, e to the x dx. So what's the solution to this one? Well, this one you need to look into it a little bit more carefully, because now you need to use integration by parts. And if you remember Lipta, you have a certain order so that you can choose the correct u. So this is logs, this is inverse function, this is polynomials, this is trig, and this is exponents. In our specific case, we have x, so it's this one. So what we are going to do is saying that u is equal to x, du is equal to 1 dx, and then we have dv, which is equal to e to the x dx, and then we have v, and we saw earlier on that this is the same, so it's e to the x, and finally v du, so is e to the x, because it's the v that we are integrating, and then with the du, which in our specific case is 1 dx, so dx. And we saw earlier on that the integral of e to the x is just e to the x plus the constant, but we're not going to do that right here. So when solving this, remember that the expression is u dv equals uv minus v du. We have this one, we have this one, and we have this one. So all we need to do is substitute. So this one, it's this one, so this expression. So all we need to do now is just do some substitution. So it's x, and then v, which is e to the x, minus the integral of this one that we know, that is e to the x. And we notice that we have the same number here, so we can even further simplify this a bit. So we have e to the x, get it into evidence, and then it's x minus 1. Notice this is the same thing, because we're doing it's e to the x, so it's this one, minus 1. So this one multiplied by the same, it's minus 1 plus the constant.